SpaceX just revealed something big buried in FAA documents. While everyone's focused on Mechazilla catches, the company is quietly preparing Starship for an entirely different landing method, one that involves massive drone ships and deployable landing legs. This isn't just a backup plan. With 120 launches planned from Florida alone, SpaceX needs flexibility. But here's what's interesting. Why would they add the complexity of landing legs when tower catches are working? The answer reveals SpaceX's true ambitions for Starship. Let's dive right in. The catch with Mechazilla's arms back in October 2024 was supposed to be the endgame. Tower catches, rapid reusability, done. But recent FAA environmental documents tell a different story. Buried in the paperwork for Florida operations are references to drone ship landings, not as a contingency, but as a planned capability. SpaceX isn't abandoning tower catches, they're building a dual system approach. So what changed their calculus? The answer starts in Florida. SpaceX has approval for up to 44 launches from LC-39A and 76 from SLC-37. That's 120 launches annually from Florida alone, on top of Starbase operations. Both sites will have Mechazilla towers, but here's the critical detail. Not every mission can afford to return to the tower. NASA missions from LC-39A and military payloads from SLC-37 often demand high-energy trajectories. The booster pushes harder, flies farther, burns more propellant. By the time staging happens, there's not enough fuel left for the boost back burn to the launch site. This is where drone ships become essential rather than optional. Unlike a fixed tower, a drone ship repositions anywhere in the ocean. The booster doesn't waste fuel fighting its way back. The landing platform comes to meet it. SpaceX has proposed landing zones across the Indian Ocean, southeastern and northeastern Pacific for ship recovery. Super heavy zones focus closer to home, the Gulf region and Atlantic. The operational range alone tells you this isn't a backup plan. When you're planning landings across 3 oceans, you're building a primary capability. But there's a problem. Current Starship has no landing legs. The entire vehicle was redesigned around tower catches after the big Falcon rocket concept was abandoned. To land on drone ships, SpaceX needs to add deployable legs to both stages, a massive engineering challenge. These legs fold inside the aft section during flight, then deploy seconds before touchdown. The modification requires reconfiguring the entire engine bay area, rerouting propellant lines, restructuring the internal framework. It's not a small change. Why go through this complexity when tower catches already work? Because Starship's mission profile demands it. Lunar missions, Mars missions. There's no Mechazilla waiting on the moon. Early Starship variants heading to other worlds need landing legs regardless. Testing and perfecting that system on Earth through drone ship landings gives SpaceX real-world data before committing those vehicles to deep space missions. Musk hinted at this back in 2023, stating about Falcon Heavy, and that's how we will land on Mars. The same logic applies to Earth-to-Earth, point-to-point travel. You can't build Mechazilla towers in every city worldwide, but you can land on legs at prepared sites. The technical requirements scale dramatically. Falcon 9's drone ships, just read the instructions, of course I still love you, a shortfall of gravitas, won't cut it. Starship generates landing thrust nearly equal to Falcon 9's liftoff thrust with Raptor 2 engines. Raptor 3 exceeds that. The vehicle, even nearly empty, weighs hundreds of tons. A Starship-capable drone ship needs roughly double the surface area of current platforms, with reinforced decking to handle the concentrated thrust loads. If SpaceX wants single ships recovering multiple vehicles per mission, you're looking at platforms approaching aircraft carrier scale. Here's where the analysis gets interesting. SpaceX currently operates 3 Falcon 9 drone ships. Those 3 platforms enabled over 250 successful booster recoveries. For Starship, covering the proposed landing zones would require at least 5 ships minimum, likely more for operational redundancy. Building and modifying that fleet represents hundreds of millions in capital investment. Each ship needs specialized equipment, horizontal transport fixtures, securing mechanisms to prevent the 100 to 200-ton vehicles from rolling during ocean transit, environmental monitoring systems. The infrastructure demand is staggering, and SpaceX knows it. Vice President Kiko Donchev recently confirmed they're converting a fuel tank transport barge into the first Starship transport ship. The current vessel, named You'll Thank Me Later, is undergoing trials. Donchev stated the plan. Initial deliveries are a single booster or ship per trip, with a plan to move to multiple vehicles per transit sooner than later. Horizontal transport from Starbase to Cape Canaveral, then eventually to recovery zones across the Pacific and Indian Ocean. The timeline? Mid-2026 for first operations, aligning with LC-39A Starship platform completion. But timelines mean nothing without solving the control problem. Super Heavy demonstrated solid control, with successful catches in late 2024 and early 2025. Ship is another story. Early 2025 saw repeated ship failures during re-entry and landing attempts. The heat shield remains problematic. Tiles fail, plasma breakthrough occurs, vehicle control degrades. For drone ship landings to work, ship must survive the entire mission profile: orbital operations, re-entry heating, atmospheric flight, and precision landing, all while potentially carrying reduced propellant margins after high-energy missions. The upcoming V3 design iteration specifically targets these issues. Improved heat shield architecture, refined control authority during the belly flop maneuver, better propellant management for landing burns. SpaceX needs consistent ocean landings first, then successful catch attempts before drone ship operations become viable. The fundamental challenge remains identical regardless of landing method. Survive re-entry, maintain control, land precisely. What makes this fascinating is the scale of ambition. Falcon 9 proved drone ship landings work. SpaceX has a decade of operational experience, a proven success rate, refined procedures. Scaling that to Starship isn't just make it bigger. The physics change. The infrastructure requirements multiply. The operational complexity increases exponentially. Yet SpaceX isn't hesitating. They're building the transport ships, modifying the vehicles, planning the landing zones, securing the regulatory approvals. The strategic value becomes clear when you consider the full picture. Drone ships don't just enable high-energy missions. They distribute operational load across the launch system. If a Mechazilla tower goes offline for maintenance or repair, drone ships provide backup recovery capability. If weather closes the landing site, drone ships reposition to alternate zones. The flexibility compounds as launch rates increase. When you're targeting hundreds of flights annually, redundancy isn't optional. It's essential for maintaining cadence. There's also the commercial angle. SpaceX plans to offer Starship to customers worldwide. Not every country can or will build launch towers, but coastal nations with port facilities, they can support drone ship operations. Land the vehicle offshore, transport it horizontally to a processing facility, refurbish, and launch again. The business model scales globally without requiring massive ground infrastructure in every location. That's the kind of operational flexibility that changes the economics of space access. So here's what SpaceX just confirmed without saying it out loud. This isn't about having a backup plan for tower catches. This is about building a rocket system that can operate anywhere on Earth, and eventually beyond it. Tower catches handle the routine missions, the cadence, the rapid reusability. Drone ships unlock everything else, the high-energy NASA missions, the military payloads, the deep space flights that can't afford the fuel to return home. Two systems, one vision. The timeline is tighter than most people realize. Mid-2026 for the first transport ship operations. Florida launches ramping up throughout the year. Ship V3 proving Reentry survivability. And somewhere in that window, the first Starship descending toward a drone ship with legs deployed, mimicking what it'll eventually do on the Moon and Mars. If SpaceX executes this, they won't just have the most powerful rocket, they'll have the most versatile. But execution is everything. Landing legs need to work flawlessly. Heat shields need to survive. Transport ships need to prove they can safely move 200-ton boosters across oceans. Any one of these pieces failing delays the whole system. Yet this is SpaceX we're talking about, the company that landed a booster on a drone ship when everyone said it was impossible, then made it routine. The next 18 months will show us if they can do it again at Starship scale. Which landing method do you think will dominate by 2027? Tower catches or drone ships? Let me know in the comments. If this breakdown added value, smash that like button, share it with fellow space enthusiasts, and subscribe to New Space Review so you catch every development as this story unfolds.